to hit record. And now that GoToMeeting control panel, you can minimize it if you go up to where the two arrows next to the X. If you click on those two arrows, it's a toggle switch that minimizes it, and then you can reopen it again.
Okay.
Click on the arrows again. But if it's minimized, it doesn't take up so much space from your screen.
Yeah, okay.
Okay. So, you want to verbalize some stuff tonight, or you want to take a picture and send me stuff?
I'll just verbalize it.
All right. That sometimes is the easiest thing to do, unless it's just a super complicated equation, but go ahead.
Okay, so it says, write an equation for each parabola with vertex at the origin.
Okay.
And then the problem is it gives focus as phi 0.
That's all the information it gives you?
Yeah.
Okay. So if the focus is at 5, 0, what kind of parabola are we looking at? Vertical or horizontal?
Vertical.
Sure didn't give you any other information than that? Did it show you a picture or anything?
No, it just said write an equation for each parabola with a vertex at the origin.
Okay. If the vertex is at the origin, then there's only one way that can be the focus. And that is if it's like that. Remember, on a parabola, the focus is always inside the parabola.
Yeah.
And it's always along the major axis of the parabola.
Okay.
Okay? In other words, it's this particular case, they've told us the focus is on the same horizontal line as the vertex.
Yeah.
That means it can only be this kind of parabola. There's no vertical parabola I could have drawn where that focus would have been inside it.
Okay.
Not with the vertex being at the origin. So they really kind of gave us two pieces of information. Vertex is at 0, 0, and the focus is there. Okay.
Yeah.
Now, let's talk about the standard equation for a parabola. There's actually two of them, and it depends on which school system you go to as to which one is used. If I'm looking at a vertical parabola, one you've used your whole life, it's always that, right?
Yeah.
So we know that this is going to be of the form x equal y squared.
Yeah.
Okay. Well, they actually use a different format when they're talking about parabolas that are conic sections. And the format that usually they use is 4p equals 4p, which goes next to the term, the variable that's not being squared. And it's equal to that. As long as there's no, if there's an x or an h, I think the standard would be this.
Yeah.
But since they've told us it's at the origin, this is all we need to work with.
Yeah.
Okay. So we know what p is. What's p?
5.
Okay. So 20x equal y squared is the answer to that question.
Okay.
Do you have answers?
I do.
Look that one up just real quick. Just
okay.
I'm 99% sure I've got it right, but I'm not looking in my book right now, so let's just make sure.
Okay.
I'm not on the wrong track.
Yeah, it's right.
Okay, good. All right, what else you got?
So I have a similar type of problem.
Yeah, there's going to be a lot of these where they give you the vertex, sometimes the focus,
yeah,
sometimes whatever. But go ahead.
So this one, you still have to find the equation for each parabola with the vertex at the origin,
Okay.
and then it's through root 3, comma 3, opening upward.
Through that point?
Yeah. And then opening upward.
Right. And so it's definitely like this.
Yeah.
And root 3 is about 1.7. We'll make that about right there. Well, we got to make it like right there. Now,
Yeah.
at least we're a little bit drawn to scale.
Yeah.
And this, of course, would be root 3 right there. And that, of course, would be 3. Okay? What else did
Okay. And then you have to write an equation for it.
Okay. So, the standard format, let me think here for a second. Well, we know it goes through 3 points, right?
Yep.
In other words, we know it goes through a point over here that is minus root 3, comma 3. I don't know if we need that, but we now know 3 points. And if we have 3 points, we should be able to work out the equation of a parabola.
Yeah.
If we start with y equal x squared, and that satisfies all 3 points. Is that not the answer? In other words, when x is square root of 3, y is going to be 3. When x is negative square root of 3, y is going to be 3. And when x is 0, y is going to be 0. I don't see that we need a vertical stretch factor. I don't see that we need a shift of any kind. Cliff, look that one up.
Okay, the answer is x minus 0 equals 1, and then y minus 0.
X minus 0 equals 1, and
Y minus 0.
equals 1. What the heck does that mean? Their question was to write an equation, right?
Yeah, the answer is x minus 0 equals 1, and then in parentheses, y minus 0.
They do not understand.
So it's just basically the writing it in like standard form. So, x minus 0 equals. So it's basically x minus 0 equals y minus 0.
Well, that's not right, though. It's y equal x squared is the equation of that parabola. All parabolas need to have one of the variables squared and the other one not squared. In other words, I think this is the correct answer, y equal x squared, because we know 3 points on that parabola. Maybe I didn't get the instructions right. You said it goes through the point root 3, comma 3, right?
Yeah, through root 3, comma 3, opening upward.
Okay. So, if I wanted to write 2 equations, and that's got to be it. That's got to be the total answer. I don't quite get this other answer.
Okay.
But nonetheless, let's go on.
Okay. And then this one is about ellipses.
Okay.
And then you have to find an equation for each ellipse.
Okay.
So this one is the y-intercepts are plus and minus 3. The foci is 0, comma root 3 and 0, comma negative root 3.
Okay.
And you have to find an equation for it.
Okay. Y-intercept is plus and minus 3. Now, do we know if it's a horizontal or a vertical?
Oh, we know, I think it's vertical.
No, it's got to be horizontal because the focus, in other words, notice that if I draw an ellipse that's horizontal through those points, the foci are on the same y coordinate.
Okay.
So you were correct. It's got to be vertical.
Okay.
In other words, that's how you determine it. Is you determine if I graph those foci, they're at 0, square root of 3, and 0 minus square root of 3.
Yeah.
And we know the foci are in the ellipse like that.
Yeah.
So whatever the axis that connects the foci, if it's the vertical axis, then it's a vertical ellipse. If it's the horizontal axis, it's a horizontal ellipse.
Mm-hmm.
And the y-intercept, so we know this number is 3, and this number is minus 3.
Yep.
All right. We got a lot to work with here. So let's see. The origin is the center is at the origin, right? Yeah, it has to be. It's symmetrical.
Yeah.
So the standard equation that we're looking for is x squared over what?
A.
Now remember the A always goes with the axis, the major transverse axis, which in this case is the y-axis.
Okay.
So we need the a squared to be under the y, and the b squared is under the x.
Okay.
Okay? In other words, this distance, what is a in this picture?
Root 3.
No, a is the distance from the center of the ellipse to the vertex.
Okay, yeah.
So it's 3. What's c?
It would be,
C is the distance from the center of the ellipse to the foci.
yeah. So it'd be, negative 3.
No, just root 3. If we're
Okay.
talking about absolute value here for a moment. But this distance right here is root 3.
Okay, yeah.
Now, what's the equation that relates A, B, and C? Because now we're going to be able to solve for B.
The Pythagorean Theorem.
It's not for ellipses. It is for hyperbolas. But for ellipses, it's C squared equals A squared minus B squared.
Okay.
Notice that difference. And one way you can always tell that you're dealing with an ellipse is notice that A has to be bigger than B. Otherwise, I'm going to be taking the square root of a negative number.
Yeah.
So with ellipses, A is always bigger than B.
Yeah.
Okay, so if I substitute and solve this, I've got square root of 3 for C equals the square root of 9 minus B squared.
Mm-hmm.
Square both sides, I get 9 equals 9 minus B squared. I don't like where this is going. I get 3, excuse me, equals 9 minus b squared. So I get b squared equals 6, b equals root 6.
Mm-hmm.
With me?
Yep.
This distance is root 6, right there, between that and that. In other words,
Mm-hmm.
minor radius, if you will. I call A the major radius and B the minor radius.
Okay.
Just kind of thinking about it like a circle, only it's a circle with 2 different radiuses.
Yeah.
Okay? So now we have everything we need to write the equation. The only thing we really needed was a B and an A.
Mm-hmm.
So what is it? X squared over what plus y squared over what equals 1? What goes under the X?
6.
Yep. What goes under the Y?
9.
There you have it.
Okay.
Look that answer up if you have that page marked,
Yeah.
just to make sure that I'm not getting any other strange kind of answers.
Okay. Yeah, it's right.
Okay, and they don't give you any of that other stuff?
No.
Wonder if that was just for parabolas. But anyway, okay. So let's see, we're doing ellipses again for the next problem.
Yeah.
Okay, then I'm going to leave that up there, that general formula.
Okay.
So we want to start all of these problems. And there's a lot of general formulas for these. In other words, the
Yeah.
general formula for a vertical ellipse is different than a horizontal. So that's vital to understand first. So what information do they give you on this next ellipse?
It says the vertices are at 4, 9, and 4, 1. And the minor axis has a length of 6.
Okay. What does the vertices tell us? This is an ellipse also?
Yeah.
Okay, here, let me put them on there. So I have a vertice right here at 4, 1. And I have a vertice right here at 4, 9.
Yeah.
So that tells me I can draw my ellipse like this.
Mm-hmm.
And it did say major vertices, right?
No, it said minor.
Well, it said minor vertices?
No, no, no. I meant it said minor axis of length of 6.
Okay. But when it gave you the vertices, did it say major? Or
No, it didn't.
perhaps if they don't say major, that's what it means is major.
Okay.
Because if they're giving you, in other words, we also have minor vertices right here,
Mm-hmm.
but they would tell you they were minor, I would think. So
Yeah.
this definitely orients us into a vertical ellipse again. So
Mm-hmm.
this is the correct general formula. In other words, if it was a horizontal ellipse, I'd need to put the A under the X and the B under the Y.
Uh-huh.
Okay. What else does it tell us? It tells us that is how long?
The minor axis is 6.
Okay. So here's the center of the ellipse. Where is the center? What's H and what's K?
Mm.
And actually, this should be, let's put those in there because they apply here. That's the real general formula for a vertical ellipse.
Yeah.
And H, we have enough information to figure out H and K. What's the X coordinate of that center?
Um.
What's the x-coordinate of both those vertices?
4.
That's the x-coordinate of the center.
Okay.
What's the y-coordinate of the center? It's halfway.
5.
It's halfway between 5. Is that what you said?
Yeah.
Correct. It's halfway between 9 and 1. You just add those two numbers together and divide by 2.
Yeah.
Okay. So we have a center. So we know what h and k are going to be in our equation. And we know everything else also. What is a?
A would be 9.
A is this distance from the vertex to the center.
Oh, it would be 6.
Here's the center. 4, 5. Subtract the y-coordinate.
Oh, yeah, 4.
So A is 4. B is what?
6.
No? B is from the center to that minor vertice. They've given you the length of from minor vertice to the other minor vertice.
Okay.
So half of that is what we're looking for.
Okay.
You get that?
Yeah.
In other words, B is this distance right here, from here to here.
Okay.
So if the whole line is 6, B is half of 6.
And
we don't need C.
Yeah.
They didn't give us any information about the foci. We don't need it. We've got enough to write our equation. Tell me what the equation is.
So it would be 4 minus 4.
Hold on. Start with x.
So x would be 4.
No. When you give the specific equation that they're looking for, you always retain your x and y's.
Okay.
You replace h with a number, you replace k with a number, you replace b with a number, and you replace a with a number.
Okay. So it'd be x minus 4 squared plus y minus 5 squared equals 1. And then
What's the denominator under the x term?
9. And then under that it would be 16.
And there you go. In other words, there's our answer. And notice why we still have an x and a y in there. In other words, every point on the outside of that ellipse is going to fit this equation.
Yeah.
If I said, is the point 10, 11 on that ellipse, well, you would substitute 10 for x, 11 for y, and see if you have an equation. Now, clearly it's not on there, but we do know a point that's on there, 4, 9. Well, if I substitute 4 and 9 in here, what do I get? 16 over 16 equals 1.
Yep.
So this is definitely fits for the one point we know, and it's going to fit for the other one also, 4, minus 1. I'm still going to have 16 over 16 equals 1.
Yeah.
Okay. All right. Did they want anything else other than the equation? Did they want the minor vertices?
No.
Okay. Just for reference, that minor vertice has to be 3 units to the right. So it's going to be a 7, same height, 5 as the center.
Okay.
This minor vertice got to be 3 units to the left of 4, same y-coordinate.
Okay.
And usually there are 7 key points on an ellipse. You're looking at 5 of them. The center, the 2 major vertices, the 2 minor vertices, the other 2 key points are the 2 foci. And we can
Okay.
figure out what those are right now because we know what A and B is, and we know C squared equals A squared minus B squared.
Mm-hmm.
So if we wanted those, we could figure them out. And then that's about all you can do with any ellipse is to identify the 7 key points.
Okay.
Okay? Are we still on ellipses? I don't want to erase that top equation if we are.
No, we're on hyperbolas now.
Okay? Go ahead and give me the information before I write.
Okay. So you still have to find an equation for this,
Uh-huh.
and then the information it gives is y-intercept at -2. The center is at the origin, and then it passes through 2, 3.
Okay. Well, let's first of all figure out whether we have. Let me figure it out down here. Ooh, what happened? Oh. If I run over, let's do this problem and then I'll let you go.
Okay.
Um, let's see. The center is at the origin. And there is a y-intercept. If this was a horizontal ellipse, would there be a y-intercept?
No.
Therefore, it's got to be a vertical ellipse. Not ellipse, hyperbola.
Yeah.
And it's got to look like this.
Mm-hmm.
Because that's the only way you can have a y-intercept.
Yep.
-2. Okay. And yeah, if I had any kind of a horizontal hyperbola centered at the origin, it would not pass through the y-axis at all.
Yep.
So that tells us that. And it also passes through this point 2, 3.
Mm-hmm.
So what's the general format for this one? And we don't need to worry about the h and the k because we know the center is at the 0.
Yep.
We still need a general format.
Mm-hmm.
Start x squared or y squared?
It would be y squared.
Correct. Y squared over, is it a squared or b squared?
Uh, a square.
A is always the distance from the center to that first major vertex. So that's going to be the a distance right there, which means
Mm-hmm.
a squared has to go into the y squared.
Yep.
Minus what?
X squared.
Over
B squared.
equals 1. Okay. Well, the fact that it passes through that point, we know what A is, right? What's A?
2 or 3.
Okay, so down here, it's 2, right?
Yeah.
So y squared over 4 minus x squared over b squared
Mm-hmm.
equals 1. You know that much.
Yeah.
And we know it passes through a point. So
Yeah.
if I put that point into this what we know, I'll be able to solve for b.
Mm-hmm.
Okay, so y squared would be 9, right?
Yep.
Minus x squared, which is 4 over b squared. All of that's equal to 1.
Yep.
So let's bring the 1 over to make that 5/4. Let's take that on the other side to make it 4 over b squared. And let's cross multiply.
Yeah.
5b squared equals 16, which means b squared equals 16 over 5, which means b equals the square root of that. But guess what? To write the equation, we really need b squared. We don't need it. So, that's all I have to do is make that 16/5, which is b squared. Now, that's the same as putting the 5 up there and leaving the 16 in the denominator. Now, that's a pretty strange looking answer. So I'd like you to look that one up before I let you go. I might have had a mistake in my calculations. Yeah, I think I see where it is too. A squared is 3, not 2. I mean, a squared is 9.
Oh, yeah.
I made it 2, and that's the x coordinate, but the y coordinate is 3. Oh, no, hold on a second. Hold on. No, I'm wrong. A is 2. That tells you a is 2.
Okay.
So, did you look it up?
Yeah, that's right.
Really? Okay, cool. You rarely see it where a is a whole number and the other one's a fraction.
Yeah.
But, okay, good place to stop.
Yeah.
Ved, I've recorded these. I will send you a link tomorrow morning to whatever email you used in the sign up.
Okay.
Let me just take a quick peek at it, make sure. I don't have it in. Oh, yes, I do. ved.colorado@gmail.com.
Yeah.
Okay. That's where I will send the link, and it allows you to review this session if you need to.
Okay. Thank you.
You're welcome. Talk to you later. Bye-bye.
Yeah.